Hi guys, my name is Lutendo. I'm going to be taking us through number patterns in preparation for our prelims. So this is a free session that the Learning Space is holding, and we're going to be doing them all throughout the week. So if you guys find that your mates are also struggling with some subjects and they also need some help with preparing for their exams, then you should recommend them to us, and then we will, we'll give you all the help you need. There is a chat that's on, so if you guys find that you're getting a bit confused, there'll be a chat open and I'll be able to see it. And when it comes up, when the question or the confusion comes up, you should bring it up in the chat. Don't wait until I'm 5 questions ahead and then say, oh, I'm a bit confused. Okay, cool. I'm just going to share my screen on my tablet. So you're not going to be able to see me, but you're able to see my screen. And then we're going to start with some revision, and then we'll do some past paper questions. And I'm hoping that you guys are engaging and that we can work together through some of the questions. Okay.
So I'm currently sharing my screen. If anyone is unable to see it, please let me know. Or if you can see it, just put a thumbs up and then we can start. Okay, perfect. Thank you guys. Okay, so we are dealing with sequences and series, and this is my favorite topic. I love this because it's always very similar questions and you don't really have to go out of your way. Maybe there's like 1 or 2 tricky questions, but if you've done a majority of the questions, then you can pretty much ace this section of the exam. And so in matric, you guys have probably covered in grade 9, 10, 11, all of them in terms of sequences. So you would have looked at sequences where you have numbers like, or a pattern like 3, 4, 5, 6, and they ask you what kind of a pattern is that, or 2, 4, 6, 8, and they ask you what kind of a pattern that is, right? And this is not being added up or anything, it's just listing a pattern, right? And so in matric, what they add is a new level where they are starting to have pluses in between these. So you'll have 3 plus 4 plus 5 plus 6. And sometimes they even want you to tell me, if I tell you that the last number is 69 or 68, what is my final sum? Like what do all of these numbers add up to? And so that's what we'll be looking at today. So we'll look at the basic ones where it's just a pattern, and we'll also look at ones where you have to add them up and see what you get at the end. Okay, so here are the most basic equations that you need to know. So for sequences, you have quadratic sequences, and these are the ones we'll go through some examples where you have a certain a pattern, but you notice that the first differences, so usually what you'll see is, okay, if I'm not adding 1 each time or not adding a certain number each time, then sometimes I'm plussing, I'm multiplying, or I'm dividing by a certain number each time. But you'll see some sequences won't have that consistency. Like you'll add 1 the first time, and then you'll add 2 the second time, then you'll add 3, and you're like, okay, wait, that's a bit odd because it's not, doesn't look like a pattern. So when you look at the first differences, they're not the same, but when you look at the differences between the differences, then you will see a pattern. And so those are quadratic sequences. And then arithmetic sequences are the ones that are a little bit simpler because you will have a common difference. You'll either be adding something each time or subtracting something each time, and it follows kind of a linear pattern that you'll be able to follow and then predict what is the next number in the sequence. And then you can also get geometric sequences, and this is where you're multiplying by a ratio. So you're either multiplying by a whole number or you're dividing by a whole number or a decimal or whatever, and you will get this constant difference or constant ratio being multiplied each time. Okay, and then for arithmetic sequences, so we're here when we have just a list of numbers, so like 3, 4, 5, 6. So this is the pattern. when you're asked to add them up, then you'll start going to arithmetic series. So that's the difference between a sequence and a series. A sequence is where it's just a list of numbers, whereas a sequence is just a list of numbers, and then a series is where you're now adding them up. Okay, I will slow down. Sorry. Okay, and then geometric series. Again, we said sequences are we have like 2, 4, 8, whatever, and then series is where we're adding them up. So you'll see it'll still be a pattern where you're multiplying by or dividing by a certain number. So 2, 4, 8, something. But here you'll have addition. So you'll be adding them up, or they can vary. It can be a plus and a minus, but you'll see a pattern in the numbers. That's how you see whether it's a geometric or an arithmetic sequence or series. And then this is when your geometric series converges, and so it goes down to a certain number. So even if the pattern continues, yes, this is supposed to be Tn or Sn, so they both mean the same thing. You can use them interchangeably. Some textbooks have Tn, some textbooks have Sn. But yeah, like I was saying here, if you continue to add the pattern, like continue to keep going with the pattern, you will get to one number, because you'll end up adding zeros when you're summing to infinity, but this is only when we have certain conditions, but we'll look at those. Okay, so let's look at quadratic sequences. So when we look at quadratic sequences, we'll see something like this, right? So normally when we're looking at patterns, we want to say, okay, what is the difference between my first term and my second term? And that kind of tells us what kind of sequence we're dealing with. So if we look at the difference between 6 and 15, what's the difference between 6 and 15? It'll be 9. Perfect. 12, 15, and 28. $13, 45, and 28. $17. Perfect. And so now we see, oh no, okay, we don't have a common first difference, so that should be a hint. Maybe it's got a second difference that's the same, okay? So what's the difference between 9 and 13? 4. And then the difference between 3 and 17 is also going to be 4, right? So now we can, bells are ringing in our heads to say this is a quadratic sequence, because we know this is the one where we have to find a first difference, then we have to find a second difference, okay? And so the general term for a quadratic sequence is Tn is equals to an squared plus bn plus c. You've probably seen this in parabolas, right? So we have like a parabola has this kind of formula, and there is a way to like relate them, but we won't go into that today. But this is the formula for a parabola, and so it's kind of like a, okay, I know I'm working with a quadratic sequence. And so for quadratic sequences, we have a set of rules that we follow, or a set of steps that we follow. Okay, so I've now found that I'm working with a quadratic, and I am going to say, okay, I have, let's see if I can make this a little bit bigger. Okay, I have a 6, 15, 28, and 45, right? And my first difference is 9 here, 13 here, and 17 here. And then the next one is 4 and 4, right? And so my first step is to find my A. My first step is to find A. And it looks like some of you have already, ooh, is it a bit shaky? Can you guys hear me? Okay, okay, okay. So I will slow down. Sorry, maybe I'm just a bit too excited. Okay, so my first step with quadratic is to find my A, right? And we always follow these steps here, the ones that I've outlined here, right? So the first step is to find my A, and I find that by saying 2 multiplied by A is going to be equal to my second difference, right? So when we were finding our differences, we said this is our first difference because this is the first like 2 numbers that we subtract from each other. So the 15 minus the 6, that was our first set of differences. And then my second difference was, this is my second difference. Right. And so to find my A, I have to say 2 times A will be equal to whatever my second difference value is, right? So here I'll have 2A is equal to, my second difference here is 4, so it's going to be equal to 4. So that means my A is, some of you have already put in the chat, well done, 2, right? So now I've got the 2 portion of my, I want to change this to a white, there we go. I've got this as now 2 as that value here in my general formula, right? So now we found A. Now let's go on to find B. Now, some of you have found, yes, perfect. So now I'm going to say, if I want to find B, and this is how you always do it. Once you find out that you're dealing with a quadratic sequence, you're going to make it, you're going to you use these steps each and every single time. Okay, so I'm just going to move up here so that we have space for my next slide. So here, so my point 2 is going to be find B. And I do that by saying 3A plus B is going to be equal to my first difference. Okay, so if I say I have already found my A, I said my A is 2, so I can substitute in 2 is there, plus B is equal to my first difference. So the first difference that I'm looking at is actually only in this row. So I'm going to look here, I'm going to look here, and I'm going to look at these first 3 numbers in my going down, right? And so now I can say 3 times 2 plus B is going to be equal to my first difference, which is 9, which is over here, because that was the first difference in my first row here. Okay, so now we can say 3 times 2 is 6, plus B is equal to 9. And so we can say that B is equals to 9 minus 6, which is equal to 3. So you're supposed to just write it below, but I'm just running out of space at the bottom there. But yes, there you go. So now we have B equals 3. And then our final step, I'm just going to write it up here. So step number 3 is to find C. And we find C. So we find C by saying, this is the last equation that we use, A plus B plus C equals the first term, which is 6. Okay, so now we have our A, which we found here. We have our B, which we found here. And now we can find our C. Perfect. So now we can say A is 2 plus B, which was 3, plus C, which is 6. Okay, so now I have 2 plus 3 is 5, plus C is equals to 6. And so C is equals to 6. I'm going to take that 5 to that side, so it becomes a minus. So 6 minus 5, which gives me 1. Right. And so now I have all of my variables. Now I can write out my formula. So my final formula is going to be Tn is equals to, what was my A? It was 2. 2n squared plus my B was 3, 3n, and C was 1 plus 1. Okay, well done. A lot of you got it. That was perfect. Okay, and so that's the formula we use for our quadratic. We'll do another practice example as we go on. I'm just going to select this and put it a little bit above here. If I can't find it. There we go. Ooh. Okay. Okay. So that was our quadratic number sequence, right? And then now we have our arithmetic sequence. And this one's a little bit different. It's not as complicated. This one's actually very, very nice. So this one has, this is the formula. We'll have Tn is equals to A plus n minus 1 in brackets multiplied by D. What does my A stand for? Does anyone know? First term, perfect. So this is my first term. Right. And then what does my D stand for? D is my common difference. So that's the difference between every single consecutive term. Does anyone know how I find my D? Let's say this was T1, T2, T3, T4. T2 minus T1, perfect. And so in this case, what is my D? Can somebody find my D? So we said D is T2 minus T1, right? And we've got here my T2 as being 10, and then minus 6, which is 4. Okay, so in a lot of cases, they won't tell you that this is an arithmetic sequence. You have to kind of figure it out, right? And so let's see what we would use to check. Okay, so my first difference is 4. So this difference between these two is 4, right? Let's see the difference between this one and this one. So 14 and 10. We can say 14 minus 10 gives me, again, 4. Okay, it looks like we're working with an arithmetic. And then let's say 18 minus 14. So this is just checking that we're dealing with an arithmetic, also equal to 4. And so we've got our constant common difference. So we know now our common difference is equals to 4, and that's going to stay the same for the rest of our terms. So what would the next two terms be if we know what our common difference is? We'll have 22, right? Because 18 plus 4 is 22. And then we'll have 26, because 22 plus 4 is 26. Perfect. And then we know that this is our formula. We know that Tn, so if I want to find the nth term, I would say Tn is equals to A, which we know as our first term, and we know our first term is here as 6, plus n. I think in our nth term, we always put our n there so that whatever we want to substitute in, we can put in. So n minus 1, and then we said our difference, our common difference is 4. And so there. Does it matter whether I put the 4 here or if I write it as Tn is equals to 6 plus 4n minus 1? Does that matter? Does that change anything? No. Right. So it's not going to change anything. You can further simplify this to become 6. I'm going to multiply this 4 in there and this 4 in there. So I'll have plus 4n minus 4. So this could be, the final formula for this could be Tn is equals to 4n minus plus 2. Okay, so that's simplified, but you could still leave it in that form and it would still be correct. Okay. So now I have a question for us, right? So let's say I was given, so I know I'm dealing with an arithmetic sequence, and I'm told that the fifth term, so T5, is equal to 23, and the 12th term, so T12, is equals to 72. They said determine the first 3 terms and the nth term of the sequence. You can simplify it. Thank you for your question, Lindy. You can simplify it or you can not. It'll be easier to work with when you're dealing with like, what do you substitute in, or like when they say, what is the T100? It's a lot easier to just put in 100 here than it is to do 100 here and then try and figure it out from there. So it would be preferable to simplify it for the long run. Okay, so here they said, what is the nth term, or what is the first three terms? Those were the first, that was the first question. Do you guys, yes. So we'll use simultaneous equations. Okay, so let me show you how to do it. So we will have, so they said T5 is equals to 23. So let's put in what we have. I know that T5, so T5, which is going to be there, we're going to substitute in there 23 because they've told us that that is there. And then A plus, what would my N be? If I'm substitute in T5. 5. So my N would be equal to 5 minus 1 multiplied by D. So I'm just using this formula that we've got here, and I'm substituting in this first bit of information that I've gotten. I was told that T5, so T, when N equals 5, which is this, is equals to 23. 23, sorry, yes, it's 23. 23. And I'm also told, okay, then we know that we can substitute N into that formula. Okay, so now we have, I can simplify this. I'm going to say 23 is equals to A plus 5 minus 1 is 4D. Okay, and the other one, I'm going to put in 72 is equal to A plus, they said T12, right? So I'm going to put 12 minus 1 multiplied by D. Okay, so now I have 72 is equals to A, 12 minus 1 is 11 plus 11D. And you guys have done simultaneous equations since grade 10, 11, right? So that means that we can solve these simultaneously. So I'm going to call this equation 1, and I'm going to call this equation 2, right? So we are going to start, which one do you want to simplify? Do you want to simplify equation 1? Or do you want to simplify or take out a factor, or isolate either the A or the D? Okay, so let's do equation 1. Perfect. Okay, so let's do equation 1. So I'm going to simplify, I'm going to isolate this A in equation 1 so that we can substitute it into the other equation. So if I'm trying to isolate just the A, I'll have 23 is equal to, 23, if I'm moving this 4D to the other side, I'm going to move that to that side, so it becomes a minus, right? So I'll have 23 minus 4D is equal to A. So now I have equation 3. Let me just add some space here. Okay, right? And so I am going to sub 3 into 2. Right? So I'll have here 72 is equals to, so now I'm saying that I found what my A is. Yeah, I said A is equal to 23 minus 4D. So I'm going to substitute in 23. Wherever I see an A, I see an A over here. So I'm going to substitute in 23. 23 minus 4D plus 11D. Now, can you see we just have D's left in our equation? So we can solve that like a normal equation. So we'll have 72 is equals to, there's nothing in front of this to give it a negative, so we can just rewrite it as 23 minus 4D plus 11D. So I'll have 72 equals 23 plus, what is 11 minus 4? Not 7. 4, 7. 7D, and then we can say 72 minus 23 is equals to 7D. 73 minus 23 is 49 equals 7D, and then to get rid of this D, we are going to divide both sides by 7. So I'll have D is equals to, well, let's keep it on the same side. 49 divided by 7 is 7. So D is equals to 7. So now we have the D of our term. So we know that our aim is to get Tn is equals to A plus n minus 1 D. So now we have our D. And so now we need to find what our A is. And we can find A by substituting what we got for D into the other equation that we didn't use. So we're looking for A. So we can sub D into equation 1. Can either put it into equation 1 or equation 3, right? Because they'll give you the same answer. So I'm going to substitute it into equation 3. And I'll have 23 minus 4D is equals to A. And so I'll have 23 minus 4. We said D is 7 is equals to A. So 23 minus 4 times 7 is 28. Is equals to A. And so 23 minus 28 is equals to minus 5. So A is equals to minus 5. And so now I have my equation. I can now say that my A is minus 5 plus my N is negative, my N minus 1, and I have my D as being 7. Okay, so now we have all of our variables. We can find what our sequence is made of, right? So we find what our sequence is made of by substituting in. So we want to find T1, T2, and T3, right? Because they asked for the first 3 terms. If I substitute in 1 into here, right, I get, let me just make it a little bit bigger, into here, I get minus 5 plus 1 minus 1, so this gives us 0. So my first term is going to be minus 5, okay? Then my second term is when I substitute in 2 in there, so I'll have minus 5 plus 2 minus 1 is 1, multiplied by 7, so minus 5 plus 7 is 2. And then if I substitute in n equals 3, I'll have minus 5, and then I'll have a 2 there, or I'll have a 3 there, so 3 minus 2 is 2. So minus 5 plus 2 times 7, which is 14, is equal to 9. So my first 3 sequences, I'm just going to say there, my first 3 sequences is minus 5, 2, and 9. Okay, then they said, what is the position of the smallest term? I'm just going to zoom in again here. What is the position of the smallest term that is greater than 268? Okay, so are they looking for a number, or are they looking for a position? They're looking for a position, right? So they're looking for an n value where the number, or the smallest term, is greater than 268. Okay, so let's see how we can do that. We have our equation, and we said our equation is, let's just simplify it. So we had Tn is equals to A plus n minus 1 multiplied by D. We found our A to be minus 5 plus n minus 1 multiplied by 7. What is this when we simplify it? I'm giving you guys 1 minute. if we simplify it and get rid of the brackets. If we simplify it, we'll get -5 plus 7n minus 7, which gives us 7n minus 12. Okay, so they're looking for where is this going to be greater, so I'm just going to erase this, greater than 268. Okay, we see that our number pattern goes from 5 to 2 to 9, which means that it's getting bigger and bigger and bigger. So eventually it's going to get to 268. We want to know what is n when it reaches 268. And so we can solve this like a normal inequality. We can say 268 is less, or this is greater, is less than minus 12. So I'm going to move that 12 to the other side, so it becomes a positive. So 268 plus 12 is greater than 7n. 268 plus 12 is 280. It's greater than 7n. And then we can divide both sides by 7. And n should be greater than 40. Perfect. So at this point, right, at n equals to 40, we actually have a value that is 268, right? Our term goes all the way to 268 at n equals t40. But they asked, what is the position where the smallest term is greater than 268, right? So here my smallest term is 268, but it's not greater than 268. And so that means my n has to be 41. So that whatever the next term is, then my smallest position is greater than 268. Okay. Does that make sense to everyone? Ooh, sorry. Okay, so in our question, they said, what is the position where the smallest term is greater than 268, right? So when we put our, if we were to find t of 268, we would get, oh, if we were to put t of 40, sorry, t of 40, if I put that into my formula, or if I put 40 into my formula, I'm going to get 268, right? But the question is asking, what is the position where my smallest term, so the term that I have that is smallest, is greater than 268, right? This is at 268, right? If I go one term further, I'm adding, what am I adding? 7, right? So 268 plus 7 equals 275. Okay. This is where my smallest term, oh, wait, sorry. Is greater than 268. So here at n, my term gives me, my term 40 gives me 268, but we want it to be greater than 268. So this is, our n will be at 41. Okay. Okay, perfect. Okay. Then our next bit, or a next very interesting question that they usually ask, is what happens when you have a variable, right? So here we're given our sequence, and they tell us that it's an arithmetic sequence. So they say consider the following arithmetic sequence. And they say determine the value of x, and then determine the value of the nth term of the series, of the sequence. Right, so I have 3 terms. They've given me T1, T2, and T3. What do I do? Does anyone have any ideas? Like, how do I go from letters to numbers to get to my actual values for T? Perfect. Well done. So we know that this is an arithmetic sequence. And with arithmetic sequences, I have T2 minus T1, or whatever the second term. So what we can generalize this is to say Tn plus 1 minus Tn will always be the same number, right? It'll always be the same number if you're dealing with an arithmetic sequence. And so if I know that these 2 numbers are always going to be the same, no matter what my values for n are, I can say T2 minus T1 should be equal to T3 minus T2, because there always will be a constant difference, and the differences have to equal to each other, right? So here, my term 2 is minus 2x minus 3, and my T1 is 2x plus 4, and that will equal to my T3, so 3x minus 1, minus the previous term, which is T2, which is minus 2x minus 3. Okay, so now we just have x's. Can you see there's only x's? So we can actually find what the value for x is, because that's the only thing we're missing. So let's factor out all of these things. So here, I don't have anything in front of this bracket over here. So I'm just going to say minus 2x minus 3. And then this negative needs to go there and needs to go there. So I'll have minus 2x minus 4 is equal to, there's nothing in front of this 3x, so it's just going to be 3x minus 1. And then here I'll have a negatives that I have to factor in. So negative times negative gives me a positive, so plus 2x, and then another negative times another negative gives me plus 3. Okay, so now I'll have minus 2x. Okay, let me just look at the groups. So let's look at everything that has x's on this side. So I have minus 2x and minus 2x. Okay, those cancel. Oh no, they don't cancel out. And then I have 3x on this side and 2x on that side. Okay, so here minus 2 is minus 4x. And then minus 3 minus 4 is minus 7 is equals to 3x, 2x, so that's 5x. And then minus 1 plus 3 gives me plus 2. Okay, so now I can move some stuff around. I'm going to move this 4x to that side, and I'm going to move this 2 to this side. So I'll end up having this turns into a negative 2, and this turns into a positive 4x. And so I'll have minus 7 minus 2 is equals to 5x plus 4x. So minus 7 minus 2 gives me minus 9, which is equal to 5x plus 4x, which is 9x. And so divide both sides by 9 to get x by itself. And so I'll have x equal to minus 1. Perfect. I see you guys have been getting it. That's good. So now we know that in all of my terms, my x is minus 1. So I see an x here, I know it's minus 1. I see an x here, I know it's minus 1. And I see an x here, I know it's going to be minus 1. So all that's left to find what my sequence actually is to substitute in my x equals minus 1. So I'll have 2 minus 1 plus 4, right? So that's my first term. Then I'll have minus 2 minus 1 minus 3. That's my second term. And then I'll have 3 minus 1 minus 1. That's my third term. Okay, what does this part give you? 2 multiplied by minus 1 plus 4. So I'll get minus 2 plus 4, which is 2. Then I have minus 2 multiplied by minus 1, so that will give me a positive 2. Minus 3 will give me minus 1. and then I'll have 3 multiplied by negative, so -3 minus 1, then it gives me -4. Okay, and so now can I see that there's a common difference? The difference between this and this is -3. And then the difference between this and this is -3 as well. Well done. Okay, so now we said my formula that I'm looking for is Tn is equals to A plus n minus 1 multiplied by D. I know my A is my first term, which I've just found here as my first term, and that is going to be 2 plus n minus 1, and then my D, I found it to be -3. Okay, and so now I can factor in, I'm going to factor in this -3 into both of those. So I'll have Tn is equals to 2 minus 3n plus 3. And so I'll have minus my Tn, my final formula, is -3n plus 5. Okay, did that make sense to everyone? We good? Okay, perfect. Okay, now we are given series. So remember we said sequences. Tejo, where do you think you need clarification? What part would you like me to repeat? So part 1, this one, or this part? Okay, so here I was just grouping these. So I was looking for all of my values with x. So I had -2 and -2x, or -2x, -2x. And then this, I was grouping this 3x and 2x because those are the things that I can group together as like terms. Does that make sense? And then, so here I had -2x and -2x. That turned into -4x. So -2 minus 2 is -4. And then 3x plus 2x is 5x. Okay. I'm assuming that is all right. Okay. Okay. I think if I'm enthusiastic, then I become too fast, but I'll try to be more enthusiastic. Okay. Okay. So now we have series. So series, before we were working with sequences, right? And so sequences had commas. It had 3, 2, 1, 0, right? And we looked at the common difference, right? Here with sequences had commas. Series have pluses, so you'll have 3 plus 2 plus 1 plus da 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 da, right? And so this one comes with a little bit of a different formula. Don't worry, this one is in your exam paper, so whenever you write an exam, you'll always see it. But like somebody brought up, it'll always have an S in. So series is like the sum. So we know plus means sum. So if I have a SN, I know that I'm working with the sum to something, right? So series work very similar to our sequences. My A is still my first term. And my D is my difference, or my common difference for each one. Right. And so, again, the difference between sequence and series is just that. A sequence is just a number of events. So like not a number of events, like a pattern of numbers that they're just listing. So you'll have 3, 5, 7, 9, right? Whereas a series now has pluses, so you're trying to add up the things that are in this pattern. So 3 plus 5 plus 7 plus 9. So that's the only difference, and they just come with different formulas that you just need to, so sequences usually have TN in your formula sheet, and series usually have SN. That's how you can tell them apart. Okay, and so again, we can work here with our series that we've been given. If I want to find what is my first term in the 6, 10, 14, and 18. Six, right? So my A is 6, and what is my common difference? My common difference is 4. So again, 4, 4, 4. So it hasn't changed from before. And so now my equation, if I want to find the sum of a certain number of things, right? I'll say n over 2 is equals to 2 multiplied by a, which is 6, plus n minus 1, and then my constant difference is 4. Right. So I can simplify this so that it looks a little bit nicer. So I'll have n over 2 is equals to 12 plus n minus 1, or 4n. I'm going to do 4n there minus 4. So I'll have n over 2 multiplied by 4n plus 8. Okay. And so the first question is, what is the sum of the first 15 terms? So what am I going to put in as 15? Which variable am I going to put 15 into? N, perfect. So now I have S of 15 is going to be equal to 15 over 2 multiplied by 4 times 15 plus 8. Okay, so I'll have 15 over 2 multiplied by 4 times 15, should be 60, yeah, 60 plus 8, which is going to be equal to 15 over 2 multiplied by 68. And that gives me 510. Okay, so that is the first 15 terms of my sequence. Okay, does that make sense? Anybody have questions? Okay, okay, cool. If they do come up, we'll come back. Okay, so here is another question. So here they can ask you, determine the number of terms in this series, right? So they give you a series, and they say, I don't know how many terms there are in the series, and I don't want to count, right? I want to know how many terms are in the series. So I know it starts with 3 plus 7 plus 11, dot, 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 and it ends at 59. Right. So I can say, what can I say? What do I do? I know my formula. Okay, let's first find the first difference. So let's find the difference between there and there. I have 3 and 7 and 7 and 11. That'll give me 4 and 4. okay? And I know my first term, so I know my A is 3, right? So can I not put in 59 at the end of my sequence? So not 59, sorry. Not 59. No, we're not going to put 59 in. Sorry, I think this was the formula that was supposed to be there. Yes, sorry, wrong slide. There we go. I was wondering, why does my formula not make sense? Okay, so this is another formula. This one you don't get on your formula sheet. So you'll have to remember this one. Yes, somebody put it in the, yes, there we go. There we go. Okay, so this is a similar formula, and I don't think it comes on your formula sheet. And it says n over 2 a plus L. Now, L stands for the last term, right? So this is the last term in my sequence. And in this case, my last term is 59. So that's what you would put. And this N tells you what? What does it tell you? The number of terms you're adding, right? And so I don't know how many terms I'm adding yet. I just know that I can put in my A, which is n over 2. My A is 3, and my last term is 59, and my Sn. So I know that my sum n over 2 is equals to 59 plus 3, which gives me 62. So how can we find that? How can we find the number of terms that we need? Or how many terms are in the sequence? So this means sum for all of these, right? And looks like we don't have the sum and we don't have this n. We don't know what that n is. So we have to pivot. So whenever you're stuck in a question like this and you're like, okay, I have the last term and I know the formula for the last term, but I've gotten here and I still don't know what to do. Like I can't substitute anything in. They didn't tell me what the sum is at the end. What do I do? So I see a few of you have already gotten it. So I'm going to use my Tn formula. And I know that my Tn formula is the one that we had up here. Oh, no, not here. Is this one for our arithmetic. So it'll be A plus n minus 1 multiplied by D. We know that this term is 59. So 59 is equals to, my first term is 3 plus, and I'm looking for my n minus 1, and my constant difference is 4. Okay, then I'll have 59 is equals to 3 plus 4n minus 4. So I'll have 59 is equals to 3 minus 4, or I'll have 4n minus 1. So I'm going to move that 1 to the other side, and I'll add it. So it'll be 60 is equals to 4n. And so your n equals to 15. N equals 15. Okay. Yes, we'll do a practice problem where you use this formula. But if you find that, so sometimes they'll give it to you as like a trick, because now you see, okay, the last term, so I should be able to do, and then you get stuck where we got stuck. And so then you can move on to using the formula and you'll be able to get your answer. So don't ever give up. Like, try another formula. If you know this is an arithmetic sequence, use another equation that you know, or another formula to do it. Okay, let's do it again. So here, they gave you the series, right? They gave you 3 plus 7 plus 11, and they told you that the something term is 59. They told you T something is 59, right? We have looked at how to find the general formula. So this wasn't the sum, we're not done. We have looked at how to find the general formula from if we're given our terms, right? And if we find our general formula, we know that it's equal to Tn is equals to A plus n minus 1 D. We said that our A was 3, and we said that our D was 4. Okay, and so now we can say Tn is equals to A, which is 3, plus n minus 1, which is 4. And I'm going to substitute it in here. I'm going to FOIL it out, not FOIL it out, distribute it so that I can have a simplified version. So 4n minus 4. Then I'll have Tn is equals to 3, or 3 minus 4 is minus 1. So I'll have 4n minus 1. Okay. So this is my general formula, but I don't know. They're asked what is the sum of the series, and I want to know what is the number of terms in the series, because I can't find the sum before I know what my n is. We're kind of like out of an n. So we have to first find n, or what position we're at, and then be able to put it into this sum formula here. Okay, so we can then say, okay, I want my T of 59. I want to know what my n is, 4n minus 1. And then that's what we did here. To say, okay, I have 59 is equals to 4n minus 1. Then I said 60 is equals to 4n because I moved that to the other side, and I found my n to be 15. All right. So now I know what my n is. I was stuck here when I was finding my sum because I didn't have my Sn. I don't know what my total sum is, and I don't know what position we're working with. Right. So now I have my position. I know what my n is. I can now find the sum, which is what they were asking, of the series. And so my Sn is going to be equal to n, which is now 15 over 2 multiplied by 62. So 15 over 2, 15 over 2 multiplied by 62 gives us 4. So S of 15 is 465. Okay. Does that make sense? Is that a little bit better? Okay. Then the last one. Finally. Okay. So now we are at geometric sequences and series. And again, series is just, or sequences are just ones where you have commas in between, right? So if I'm looking at a geometric sequence, this is the formula I'm going to use. It's going to be Tn is equals to A and then R to the power of n. It's going to be A times R to the power of n minus 1, right? So there's a multiplication in between there. Okay, so what we're going to do is, what is my A? Oh, sorry, I can't point to it. What is my A? My A is going to be 2. And then how do I find my R? T2 over T1. Perfect. Well done, guys. So I have T2 over T1. So I'm going to choose just, yeah, the 6 and the 4. So I'm going to say 6 over 2, and this gives me 3. Let's check it with the other ones. So this should be equal to T3 over T2. So let's check that. T3 is 18 over 6. So this should give us 3. Okay, and even if we checked it with 54 over 18, we will get 3. Okay, so now, again, general term is very nice and simple. I know my general term is Tn is equals to A r to the power of n minus 1, which is equal to A, which we said was 2, multiplied by r, which we said is 3 to the power of n minus 1. Okay, so this is my Tn. And then they didn't ask me for, so what would the next term be, just for the verbs? $162. Perfect. So we just multiply 54 multiplied by 3. Well done. Okay. Now we have a common question. Here we have been told that I have this geometric sequence, and I want to know what is the value of x and what is the formula for the sequence. So we did something similar when we were doing arithmetic. What did we do? What did we find first? What was our step 1? T2 over T1, right? And then we're going to equate it to, my handwriting is so step, didn't get better. But yes, so we're going to find the common ratio, or we're going to use the fact that we know that the common ratio is going to be the same, right? So we know, we found even with this one, that when we said T2 over T1, it was the exact same as T3 over T2. So we're going to use that kind of edge that we know. So T2 over T1 must be equal to T3 over T2. So whatever the previous one was, so T3 over whatever the previous term was. T2 we found is x. T1 is 4x minus 3 is equal to T3 is 2x minus 5 over T2, which is x. Okay. Ooh, sorry. There you go. Okay. What do we do first to kind of get rid of all of these fractions? So I'm gonna multiply this side by x, or both sides by x, right? So I'll have x squared over 4x minus 3 is equals to this x cancels out with this x, gives me 2x minus 5. Yes, cross multiply. And then I'm going to multiply both sides by 4x minus 3, multiply it by 4x minus 3. Okay, let's give myself some more space. Okay, 4x minus 3. And then I'm going to say, okay, now I'll have this 4x minus 3 cancel out with that one. So I'll have x squared is equals to 2x minus 5 multiplied by 4x minus 3. Okay, now I can FOIL, right? I'm going to do that one, that one, that one, then that one. So I'll have on this side x squared is equals to 2x multiplied by 4x is 8x squared. Then 2x multiplied by minus 3 is minus 6x. Then minus 5 multiplied by 4x is minus 20x. And minus 5 multiplied by minus 3 is plus 15. So for the cross multiplying, I just said I'm going to multiply So first I started by saying I'm going to multiply both sides by, so if I had like just a normal one, if I had 2 is equals to 3 is equals to x over 2, I would say I want to get rid of this 2, so I'm going to multiply both sides by 2, right? Then I'll have 4 equals x, right? So here I'm going to do the same. I want to get rid of these fractions, kind of. So I'm going to multiply this side by x and multiply this side by x, right? So this cancels out with that, and then this x is multiplied by this x to get me x squared. And then for this other fraction, I'll multiply both sides by 4x minus 3, right? And multiply by 4x minus 3. And then you cancel that out, and you're left with this multiplied by this. Or you could have seen it as LCD, yes. So x over 4x minus 3 is equals to 2x minus 5 over x. My LCD is then x 4x minus 3. Okay, so what is this one missing? It's missing a 4x minus 3. So I have to multiply 4x minus 3 over 4x minus 3. And then this side is missing an x at the bottom. So I have to multiply it by x over x. And so I end up with x squared over x, or x minus 3 is equals to 2x minus 5 multiplied by 4x minus 3 all over 4x minus 3. And because they have the same bases, they just fall away. Okay. It's not necessary, especially when when you with the whole thing in the denominator, I'm multiplying by everything in the denominator. So it's not necessary. If you can do it correctly in your head, then you don't have to show this whole process. If you know that if I'm starting from here, and I know that these bases are just going to be swapped, so that's going to go there and that's going to go there, then you don't have to show that. Oh, where is it the most confusing? Okay. So, okay. So if we have x over 3 is equals to x squared over 4. And I want to get rid of the denominators. What am I going to do? So this is a separate question from what we were doing now. So you can cross multiply, or you can find LCD. Both of them are the same. So if I was to find an LCD, that would be 12, right? So if I want to put my LCD on both sides, I would have to say this has to be 3 times 3 to get to my LCD, and this has to be 4 over 4 to get to my LCD. Right. So I would end up having here on this side, I would have 4x over 12, and I would have 3x squared over 12, because I have 4 times 3 here and 4 times 3 then. Okay, so now I have the same bases, and when you have an equation and you have the same bases, you can drop them, because what you could do is multiply by 12 on both sides, and both of them would cancel out there. So we can drop those bases. So I'll have 4x is equals to 3x squared. Right. Is that a little bit, did you get that, Bui? Okay, I see Bui said no. I don't know how else to explain it. Okay, I can just give you a rule. X over 3 is equals to x squared over 4. Whenever you see two fractions with an equals, you're going to find this and multiply it by that, and take this and multiply it by that. So it'll be 4x and 3x squared every single time. If you find a fraction equal to another fraction, you're going to take the base multiplied by the top of the opposite side. You're going to take the base and multiply it by the top of the opposite side. Okay. 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 So, ooh, such a small eraser. I don't know how to make it bigger. Okay, so here we're just going to continue. So hopefully that makes a little bit more sense. Okay, so here we were doing we've just cross multiplied everything that we needed to cross multiply. So now I have x squared is equals to 8x squared, oh sorry, it's just, yeah. So 8x squared, these two are similar, so minus 26x plus 15. Okay, then we can say that I want all of my x's on one side. So I'm going to move this x squared to the other side. So I'll have 0 is equals to, if I move that to that side, it becomes 7x squared minus 26x plus 15. It's going to be a very nice looking number, but that's okay. How do I do this? So we can use the quadratic formula because it looks a bit complicated with all of our different things. So our quadratic formula says minus b plus minus square root of negative boy couldn't decide whether to go to red party being square. He decided not to go and Mr. Wilson checks. Party was over until 2 a.m. So we know how to use the quadratic formula. And so when we substitute in what our a is, which is 7, what our b is, which is minus 26, and what our c is, which is 15, we should get x equals 3 or x equals 5 over 7. Right. And so those are the two values. So here we can actually take this hint over here. They said values. So you could have gotten one answer or two answer. So we got two answers for x equals 3 and x equals 5 over 7. Okay. And then we then put it into we can then find our, ooh, that's too small. So we said x is equals to 3 or x is equals to 5 over 7. So I'm just going to do it for 1 so that we can still do some past paper questions. So if x equals 3, then I have my sequence being 4, 3 minus 3, and then 3, and then 2, 3 minus 5, right? And so I'll have 4 times 3 is 12 minus 3 is 9, and then 3, and then 2 times 3 is 6, minus 5 is minus 1. Okay, is it minus 1? No, it's 1. It's just 1. Yeah. Yes, we are. We are going to cover sigma. It's coming up just after this. Okay, so here we can find then our r is 1 over 3, right? Because we're dividing by 3 each time. If we say 3 divided by 9, we get 1 over 3. 1 divided by 3, we get 1 over 3. So our Tn is going to be equal to A, which is going to be 9, multiplied by R, which is 1 over 3 to the power of n minus 1. Okay, so this would be our formula for this one. Okay, cool. And then we've got, there we go. Then we've got series. And again, our sequences are just 3, 2, 1, 0. Series are 3 plus 2 plus 1 plus 0. And sometimes they ask you for the sum, right? So here, again, very similar to the way that we did it before, is we have our formula, and you know that it's a sum formula if you have Sn. And so Sn tells you that this is a formula that you can use. Yes, you can use both x values. Sorry about that. I just didn't want to, but you use the same formula for both. So you do the same thing. So for 5/7, you would still also put in 5/7 there and 5/7 there and 5/7 there, wherever you see an x, right? So you put 5/7, 5/7, 5/7. So you show that these are the two options for my pattern. Okay, so this pattern can work with two different x values. Okay, we'll have a chance to practice something similar to this again in like a past paper question. Okay, so here, or maybe I'm moving too fast in terms of moving up and down. Okay, so here again, you're just given your formula. And so you can have Sn is equals to A is still my first term, Rn minus 1, R minus 1, R is still my difference between my two terms. And in most cases, they'll ask you, what is the sum of the first 15 terms or something like that? And so you can use your formula. You know that your A is 2. And what is your R in this case? I think it's the same. R equals 3 still. So if I want the sum of the first 15 terms, I'll have 2. And then R we said is 3 to the power of n minus 1 over 3 minus 1. Okay, and so this will be, oh, sorry, this is 15, right? Because they've given us that they want it to be 15. And so our sum of our first 15 terms is going to be 2, 3 to the power of 15 minus 1, and then all of this divided by 2. So you should get 1, 4, 3, 4, 8, 9, 0, 6. Okay. So this one's nice and simple because you don't have to do a lot. You don't have to try and figure out a lot of different stuff. Okay. And then for geometric series, right, they can either converge or diverge, right? So converging is a very nice like concept to think of. If I have, let's say, 1 and my R is a third, what's my next sequence going to be? What's my next number going to be? My R is 1 over 3. 1 over 9. Then the next one is going to be 1 over 27. The next one is going to be 1 over, plus 1 over 81. The next one is going to be 1 over 243. And the next one is going to be 1 over 729. And going and going. What is 1 over 729 in terms of like a decimal? you'll get something ridiculously small, like 1.37 ... times 10 to the minus 3. That's 0,000, wait, 1, 2, 3. Oh, it's 0,13. So it's quite small. Like you're basically adding 0,000. Like as you go further and further, you're going to be adding smaller and smaller and smaller numbers, right? Ooh, so we're doing convergence and divergence of geometric series, right? And so when we say that a series converges, it means that as you go towards the end of your series, you're going to basically be adding zeros. So like when you get to 1/1000 and whatever, right? You are going to be adding zeros essentially. So that means that when you add up all your numbers, like going all the way to infinity, you'll actually get a solid number. Because after this, you're basically adding zero. Your number's not getting any bigger. So when they say a series converges, it means that the ratio between each term, so like what you're multiplying between each term, makes each term smaller going down. Okay, I'll slow down a little bit. So we're looking at, so we know that geometric series is where you multiply by a certain number each time, right? Okay, we're starting again here. So we know geometric series and sequences is where you're adding by a certain number each time, or multiplying by a certain number each time. Let's see. Okay. We've said geometric series is where you have like 2, and then this 2 is multiplied by another 2 to give you 4. And this 4 is multiplied by another 2 to give you 8. And this 8 is multiplied by another 2 to give you 16, right? So you're multiplying by 2 each time. Okay. All right. So that's geometric series. There are some geometric series that when you multiply, like the more you multiply, your number is getting smaller, right? So let's say I start at 3 and I multiply by 1/3, right? If I multiply 3 by 1/3, what do I get? I get 1, right? And what if I multiply 1 by 1/3? What do I get? 1/3. And if I multiply 1/3 by 1/3, what do I get? 1/9. And if I multiply 1/9 by 1/3, what do I get? 1/27, right? And I can keep going. I'll actually tell you what, like a very, very small one I could get times 1/3. So we got in the previous one I was starting before, we got to 1/729, right? And when we put this in our calculator, if you try to find a value for it, what is the value? So like when you press SD on your calculator, what do you get? You should get a very long looking number. Something like 1.3 something 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 times 10 to the minus 3. Yes, right. So you'll see it's like a 0.0013, right? If I go even further, I get 1 over 2,187. This is actually 0.0004, right? If I get, so this is this multiplied by 1 over 3. If I multiply this by 1 over 3, so I'm still continuing with the sequence, I get 1 over 6561. So none of these numbers are important, so you don't have to like really like dig into them. I get 0.0001 dot dot dot, like it keeps going, right? And so the bigger this number gets, right, or the more times you multiply by something that's less than 1, right, or bigger than -1. So that's the boundaries for this. The smaller the number is going to get. So by the time I get to infinity, but even here, when I get to this point over here, I'm basically adding zeros. Like the number that I'm adding, let's say my number was 3 before. 3 plus 0.0001 is basically 3, because you're adding such a small number, right? So what we're doing when we find a sum to infinity is we're saying when we get to infinity, what is the sum going to be? And we can't get to infinity, right? Like it's all like theoretical. But if we were to continue adding numbers all the way up to infinity, I can see my trend here that I'm not going to get any bigger numbers. Like my numbers are just going to keep getting smaller and smaller. Like I'll get to a number that's 0.000000003. And that's also very close to 0, right? And so we say a number converges. This is the most important part, the only important part. If the R is between -1 and 1. So you can have an R of -1 over 3 or -1 over 2 or 0,005 or 0.85. Anything between the number line of -1 and 1, right? So as long as it's not a whole number. If it's a number like 3, then your series is not going to converge. It'll keep getting bigger and bigger and bigger. Like we had here, if I add 32, like as I go to infinity, this number is just going to keep getting bigger and bigger and bigger and bigger and bigger. So it'll never get to a small, like a finite number. But if your series is convergent, then you will get to a definitive number, right? And so you say that it has converged when it's gotten to that number. And the way that you can tell if a series is going to converge, you don't have to keep adding numbers after the other, is if you see that your R is between -1 and 1. That's how you know that your series is going to converge. Okay, does that make sense? Okay. Okay. So the most important thing is if you find your R value to be between -1 and 1, then you know that your series is convergent. If it's a whole number like 1 or 2 or 3 or 4, then it's not going to converge. It'll keep going on and on and on, getting bigger and bigger each time you add another part of the series. Okay. So then we then have here a question. So with this convergent series, then we can have sums to infinity, and the formula, let me just check, other one was a bit off. I think it's correct. I just couldn't find a way to put an infinity there. Yes, this is fine. So you can then get asked, what is the sum to infinity of the sequence, right? And the sum to infinity is this formula here. I just couldn't get this to be an infinity sign. Is going to be equal to A, your first number, 1 minus your R, right? in this case, what is my R? What is the number that I'm going to from there to there and there to there? One over 2. So my R is equals to 1 over 2 or 0.5. So, right. So now my sum to infinity is going to equal to A, which is my first number, which is 1, and then 1 minus 1 over 2 or 0.5. They're the same. So my sum to infinity is actually going to be 1 over 1 minus 0.5, 2. So no matter how many terms you add to this, it's going to end up being just 2. So this is called a converging series because it goes to a certain number, which is 2. A divergent series wouldn't go to a certain number. It just keeps getting bigger and bigger and bigger. Okay, so one of the questions that they like to ask is the series convergent? And so what you just need to do is find what your R is, and if your R is between -1 and 1, then you know that your series is convergent. Okay, I just want to do sigma, then we'll come back to, sigma is a bit different. Then we'll come back to, oh, what's the reason for? If it's divergent, you can't use this formula. So if you have your R being greater than, like an actual whole number, or greater than 1, then it won't be. So this one is convergent because the R value is less than, is between -1 and 1. But the sum, it adds up to, if you add all of these numbers up, they'll add up to 2. So that's why we say that it's convergent. Okay. And then sigma notation. This one isn't actually that bad. I don't know why people are scared of it. So sigma notation is just basically a way of showing a sequence, or no, sorry, a series, which is where you have addition. Sorry, we still have 20 minutes. Okay, so let's say you have a big sequence. Or sorry, even I'm getting it wrong. A big series. So you have so many numbers that you're adding up, and you really don't want to write out the whole series and then end up getting confused and like, yeah, it's like a lot. So you can use sigma notation to represent what you want to say. So with sigma notation, you'll have your number pattern, and you can always find your nth term for your number pattern, right? So they'll give you, we'll look at one, no, we won't, but we'll look at a way to calculate sigmas. They'll give you your 2, 4, 6, 8, right? And they'll say, write this in sigma notation, right? So what you need to do is first find your TN version of this series. So I know my first term is 2, and then my D is 2. So I'm just going to say n minus 1 D. Oh, sorry, 2. 2, right? So if I simplify this, I'll get 2n. Is it? Yes, I'll get 2n. Right. And so I want to show that this thing goes on for 7 rounds until n equals 7. But I don't want to write it all out because it's too much work. So what's your sigma notation? This is your Tn formula. So if you're ever asked to write something in sigma, find your Tn, right? And, or if you're asked to translate something to sigma, what you'll do is, it says it starts at x. So this is your starting point, and this is your ending point, right? So where you start is what you're going to substitute in first, right? So let's say you're asked to expand this. Let's say it wasn't here on the work. Nope. Okay. Let's say you're asked to expand this, right? You are given, I'll move it to the side, so 4x minus 3. 4x minus 3 sigma. It starts at x equals 3 and ends at 7. So you are going to substitute in from the start of x equals 3 to 7. Those are your different terms for your sequence. So the first one is 4 multiplied by 3 minus 3. So this is your first term. Your second term says, what is 3? What's the next? It's 4. So 4 multiplied by 4 minus 3. So you're going to be counting up from 3 up until 7. So you're going to have 3, 4, 5, 6, and 7. The next one is 4 multiplied by 5 minus 3. The next one is 4 multiplied by 6 minus 3. And the next one is 4 multiplied by 7 to get to, oh, minus 3. I don't know why it just, okay. And so we can do this. What is 4 multiplied by 3 minus 3? So we have 9. We have 9 plus 13 plus 17 plus 21, I think, plus 25, right? So this is your now series, and you can find the sum of this either by just like adding all of these things up, because there's only 1, 2, 3, 4, 5 of them, or you can use your sum for arithmetic sequences, because this is adding 4, adding 4, adding 4. So you can just use your T end is equals to A. Oh, no, so you use your SN formula, which is further up in our thing. So you can use your SN is equals to N over 2. Oh, I haven't memorized it. Yeah, we had it at the beginning. So you just use your SN for your arithmetic to find what the sum is for these, right? Okay, and then so yeah, so here, if I'm given, let's say, actually no, let's do a past paper question, because I think that would be a bit nicer. So let's do, okay, yes, like this, right? So they say, represent this using sigma notation, right? So we see this and we're like, oh my gosh, I don't know what to do. So I'm just going to write my sigma. I know this is my start, so it has to start at x equals something. So this is my start. And it has to end at something. This is my end, right? And so I'm going to see, can I find the general formula for this thing? I have 4, 9, 18, 31, and 48. What's going on here? Is it an arithmetic or geometric? Yes, you can use SN, Cabello, even if the numbers are small. So are we dealing here with an arithmetic or a geometric sequence? Or series, sorry. Or quadratic, maybe it's quadratic. Oh, sorry. So let's see. So we have 4 and 9, so this is 5. 9 and 18, which is 9. 18 and 31. 13. 48 and 31. Yeah, So it's a quadratic, because then here we have 4, we have 4, and we have 4. And we've practiced quadratic. We said to find a, we say 2a is equals to the second difference, which is 4. So my a is equals to 2. So I'll have a equals 2. Then we said 3a what is it? 3a minus what? Minus 1 is equals to 5. So we can then say 3a is equals to 6. And so, oh, sorry, this is b. So that means, oh no, wait, 3a minus b, sorry. Three a minus b is equals to 5. So 3 multiplied by 2 minus b is equals to 5. So minus b is equals to, this is 5. This is 6 minus 5. So is it plus? Sorry, guys. So this is going to be 6, but it's going to be minus 6. So b is going to be minus 1. Sorry, guys. Yes, it is plus b. Okay, so b is equals to minus 1. And so we can say a plus b plus c is going to equal to 4. And so a is 2, b is minus 1, plus c is equals to 4. So 2 minus 1 is 1, plus c is equals to 4. So c is equals to 3. Right. Okay, so now we have our formula for this to be Tn is equals to 2n squared plus or minus n plus 3. No, I'll be okay. Thank you, Tava. So this is our formula, and this is the formula we put here in our sigma. So 2n squared, or x, because we're using x as our x minus x plus 3. Okay, so when we started here with our first term, what did we substitute in to get that first one? What x did we substitute in? 1. So we can start at, oh, I should never erase that. 1. Right. And then they tell us it ends at 949, right? So is there a way that I can find out what term number that is? How can I find that? Can you guys find that for me? As you test to see if you've been paying attention. So we said 1 because it's the first term. When we got 4, or when we get 4, we always start at n equals 1, n equals 2. So it'll always start at 1 unless they give you 1 at the end. I won't. We'll be done in like 9 minutes. So I think my battery will survive till then. So it'll always start at 1. When you're writing the sigma notation, you'll always start at 1, because when you make your term, your general solution, you are assuming that you're starting at n equals 1. So it'll always be 1 when you're writing the sigma notation. Okay, and so I'm seeing a lot of 22s. So here we go. 22 is going to be our top bit. And now you've written in sigma notation. Because now if I was to look at this, let's say you've given me just the sigma notation, and you said of 2x squared minus x plus 3, and you're telling me that x starts at 1 and it finishes at 22, I can replicate this sequence and tell you where it ends. I can tell you that last term, because when I substitute in 22 into there and there, I will get 949. Okay, so your first step was to first find out, what am I dealing with? Am I dealing with a quadratic? Am I dealing with an arithmetic, or am I dealing with a geometric, right? So that was my first step. And here we found out that we're dealing with a quadratic. Then we found the general term for that quadratic. So, right? So now we know what my sequence is going to look like, no matter what x I put in, right? Sometimes they can tell you to put x, sometimes they can tell you to put in. It doesn't matter what letter you use here, right? And then you fill in your sigma notation. You know that you always start at 1. When you are writing the sigma, you're always going to start at 1. And then you find, what is t of this last thing that you have here? What is that term? What is n for that term? And here we found it to be 22, and that will be the top. Camilla, what's going on? Yeah, so you're not supposed to, here they said just represent it in terms of sigma. You don't have to. Yes, yes. Sorry, maybe let me do that part because you guys did it independently. So here I know that my last term is 949, right? And I found my general term to be Tn is equals to 2n squared minus n plus 3. And I want to know, what is my n at when my term is 949, right? So what is my n at 949? So I can say 949 is equals to 2n squared minus n plus 3. And then solve this as a quadratic. I'm going to move this to the other side. So I'll have 2n squared minus n minus 947, no, 6. Right? So now I'm looking for, what is n, what are the possible values for n? And so you can use the quadratic formula, or you can use your calculator. I'm not sure what calculator you have. Minus b plus minus square root of b squared 4 to n. Do you know how to use the quadratic formula? Carabello, or is it Carabo? Who is this? Cabello. No, there's Cabello. Okay. Oh, yes, yes, I can definitely. So you use your quadratic formula to find your two, you'll find two values, but one of them will be a negative and you can't use a negative position. So the other one will give you 22. And so your n is going to be equal to 22. And that will be what your term is at the end. So this is the last term, and this has to correspond with the last position that you have. Okay. So I'm going to leave this here for a bit so that you can take screenshots if you want to. Let me just add 8.3 there. And then I will show the other one in 5, 4, 3, 2, 1. The other one we were doing sigma, or sigma notation, but this one wasn't that that explanative. So you had this, and so you're going to start at 3, end at 7, and you're just going to be substituting in the 3, the 4, the 5, the 6, and the 7. Oh, Tafara, can you help? How can they access the recordings? I don't know if Tafara is there. So we'll do logs. We're gonna do, I think it's functions tomorrow. Let me just check. Let's see. So tomorrow is unfortunately, unfortunately, but fortunately, physics. So if you're doing physics, tomorrow is momentum and impulse. But on Wednesday, we're going to be doing functions. And so you can come back for functions and we'll do log functions and all of that stuff. And then if you'll probably get an email because you signed up to this. So you probably get an email before after you sign up to this. So it'll tell you all the dates that you have, and it'll give you the links to all the future ones and the links to all the recordings that we do. Okay, does anyone want me to scroll back to any point here that we did? This is the divergent one. And then yeah, all the other ones, but this will all be shared with you, so you can still have it for future reference. Okay. I'm glad it was helpful. Okay, so the lesson is going to be over. It'll just go back into the music. But yeah, use that link to find everything that you need. All the recordings as well. Okay. It was so nice being with you guys. Have a good evening.